Hey, thank you, Inti, for this nice introduction. Let me see. Okay, can you see the screen now?
It's perfect, yes.
Okay, perfect. So, well, as we heard now, very exciting developments. And when we started with digital pathology, we thought it would kind of be easy, but we learned now that there are a lot of hurdles to take to bring these fantastic developments into the daily routine in clinics. And that's why I have chosen the title A Long Day's Journey into Digital Pathology, not into the night. But, you know, sometimes it sounds like as if we were going into the night, but we are not. So we are not the first one to have such a meeting. And look at this, what I found. In 1969, there was a symposium on automation and data processing in pathology at a time where computers filled a whole room and there were no monitors. All you had was a pile of paper printouts to get your results of all your programs you have been running. And most interestingly and very, very actual, the conclusions of this meeting were like this, that there is no doubt that automatic methods of analysis are capable of making our lives easier. They reduce labor costs and increase speed. They're important companions in the lab today and will be increasingly in the future. Well, but not so the computer. It's a hard taskmaster demanding considerable wisdom and often intuition to interpret its output. So that's very funny, isn't it? So for many years, it will make life difficult if you are used if we are to use it properly. And if we do not, then we risk ossification in a mass of data. That's almost more than 50 years. And I think has some actual meaning in these times today. So why digital pathology and routine at all? So we have heard quite a lot, computer-aided image analysis. That's one of our main topics today. Image documentation, integration of imaging boards and reports, comparison with previous specimens, paperless work, of course, no wrong slides anymore, and home office in pandemic times, which is very important. We have experienced a lot. So, and there's a big hype going on. And of course, we are part of that hype. And that hype is that big that some people thought, oh, wow. Well, we're probably one of the highest paid doctors. I've never noticed, but obviously I am. But soon I will be obsolete, obviously. And not only pathologists, but also radiologists, according to the media. And that leads us to the hype cycle that you're probably familiar with the Gartner hype cycle. So after innovation trigger, it comes really to a big hype where everybody is enthusiastic about everything. That ends up in a trough of disillusionments. Things are not going that fast. They're not as accurate as we think. And finally, after this, we come into a slope where it all adapts and when we can use it properly. So I think in terms of AI and digital pathology, we're somewhere around here. So we have many adopters right now and very enthusiastic people. And we're coming probably soon at this part of the curve as we see that the problems we're facing are not that easy to manage. So as Inti said, we have been starting very early and like in the stone age of digital pathology, and like in 2011, when we started about thinking in digital pathology, that was the time where not that many scanners were available. So we started out with a scanner with 4 places for slides, and scanners with more than 100 were all still in the pipeline and not certified at all. So, and as you see, when we started with the proposal and when we finally got an order in 2012, it took us almost a year to get everything established. And that was quite of a hard time. And I was really surprised that we had such a lot of workflow analysis to do and questions to be answered we have never been asked before, and really to see what do we really want with that. And the big shock came in 2016. We were starting with a big company like GE in order to have like some advantages of the PACS platform we also have for radiology. And in 2016, GE said so they want to terminate their DP activities. So there was a time that was really shocking. And I was, very much around to see who could succeed, who could be a successor for our system. And I learned then that the companies are not very happy if they talk about data migration, because we had accumulated quite a lot of scans and quite a lot of annotations and also tests. And the firms were not very happy to migrate all this data. But luckily, we had a company that took over the GE software, and we could sign in 2018 a contract with this vendor, and we could save all our data and continue with the digital pathology. But however, that required an update. And again, as you see, to make all this update and set up all the new interfaces took us almost another year to get this all done. So again, we had to go on scanner pilots and tests. We had to go through workshops and interfaces and really start again. Finally, we could new scanners install and really succeed with a fully digital workflow. And in April, we were moving to our new institute. So just to highlight what it means to introduce digital pathology in a daily practice, that means you need about 10 to 12 persons involved in your local working group. That includes a group for workflow and pathology, the integration of LIS and the digital pathology software. Then you need somebody for the software engineering, application specialists, scanner hardware is also a big topic, and also the IT infrastructure. And all this needs to be really brought together that you can run a very nice system. So that is the setup we have in Aarau right now. As you see, all our servers, which are 6 of all, we are located in Olten, which is like 15 kilometers from Aarau. So for this, we have 2 times 10 gigabit dedicated line that gives us a latency of less than 1 millisecond. So we can really work properly with all our scanners and all with all our workstations to get a smooth workflow in this. As I said, we have 6 workflow servers, or 6 servers, which are listed as here. We have a workflow server, we have a digital archive server, database server, and of course, job agent server. We have a web server and web server for the demilitarized zone, which all for all external incoming connectivity done to our digital pathology software. And I was astonished that really so many servers are needed. And of course, they all need to be set up and hosted, and also be prepared for all the incoming data and management of all this. And that brings us to system requirements. And you might want to consider that these are the minimum requirements for a digital pathology platform. And that includes, of course, the CPU cores and the memory and the drives. And that really needs to be properly set up, because if you have not enough memory space, then you run into big problems. This is all calculated for 10 users, which is our institute currently available. But think ahead. If you introduce it, the time will come then when you want to have more. And with this, it's not just buying a new computer or a new monitor. With this, you need to increase also your CPUs and RAM. And that goes through all your web servers and the other servers. And you might take into consideration, once you expand, that you also have to expand on your server side. It's a little easier for the workstation, because the workstation is really not that big of a deal. And as you see, monitors have been in the past very big topic. And as you see here, these are the requirements for our digital pathology system. And if you look here, it's just not really a big of a deal. So we tried various monitors with all calibrations, automatic or manual, or resolutions and pixel. And at the end of the day, we found all of these monitors are suitable. So depending on what kind of preference you have, you may choose the minimum or a high-end monitor whenever suitable. So things you want to do in digital pathology setup. So I really can recommend have all the players involved early. Otherwise, you might run into serious problems. And do a workflow analysis and ask yourself how much of your workflow is already digitized. And most important, define the steps you want to improve. That brings us to the very, very important questions. What do I really want with digitization? Is it just, technology, or do I want to improve in my works, in my digital routine something? Have contact to your LIS provider for the integration. That's very important because other than in research, you need a strict and 100% reliability or connectivity from your slides to your patient data and your referring physician. Ask yourself, how do you want to work? Do you want to work from the DP system, or do you want to work from your LIS? That is very important questions, because that has impact on your integration, on what kind of system you might want to choose. Choose a system that fits, of course, your needs and is flexible for future developments and scanner integrations, because most of the scanners have various file formats, and not all the DP systems support those. Address early special functions, as we have heard earlier. Fluorescence may be a subject in your lab. What about Z-stacking? Are you using that? And image analysis tools. That's also very surprising. Finally, you don't want to work with like 2, 3, or 4 softwares on your workstation. Ideally, you have the scanned slide, you want to review that, and then you want to use analysis tools, either image analysis or artificial intelligence, but you don't want to switch between various softwares back and forth, because that's not very convenient. So talk to your DP provider, how are these analysis tools implemented? And it was surprising to me that that is not that easy, as many vendors almost very often tell you. And choose an open platform is important. Well, since we came from an early time where there was no working possible from the LIS system, we had to choose a system where we have been working from the DP system and had a connectivity to our LIS system. That means that we have the master system is our lab information system, or the pathology system, and everything that is done is somehow transmitted to the digital pathology system. In order not to double, to reproduce data and double store them, especially for previous reports and older data, we have SQL query report that is active only once I hit the case. And after I close the case, all this data is deleted again and not double stored. Of course, you need to maintain your data procedure and providers that is updated. Otherwise, you run into problem, because once the slide is scanned and you don't have all your providers and procedures documented in your digital pathology system, you might run into errors and mismatch of your slides. So how has it happened from our lab system? We have such a button which is easily, once the case is assigned to a physician, we can have a little icon over here, and it says transmitted also into digital pathology. We're currently working to set up this interface that this is done automatically. So just to give you a brief overview, what was the workload in 2021? So if we go in fully digital, we have about 1,100 slides a day. This is averaged over 256 work days. So that leads us to scanners, because then scanners are the real bottleneck on this one. So in between, there are various models on the market, and of course, not every model is really suitable for your lab. And once you see those, I can really recommend have those scanners tested in your lab. And the workflow with the scanner is not the scanning process itself, but it's the whole workload, starting process and calibration, loading, handling the software. What about the loading? What about the scanning process itself? What about the scanning time, which is mostly advertised by the vendors and runs between 30 seconds and 1 minute, and the time between scans, and the scanning problems, software or hardware. So what about problems in tissue recognition or in the focus? What about the unloading and the fluorescence and Z-stacking and the file size? And you see all this leads you to a longer scanning period than just the actual scanning process. So we have been testing 4 various scanners in 2018. At that time, we had probably the up-to-date models in our lab. And we were really surprised that some scanners really have special requirements, and that also has to fit the needs of, these needs have to fit the environment of your lab. In terms of shock resistance, is a regular bench in your lab enough, or do you have special shock resistance tables? Dimensions of the device is really a big point, and as you've seen here, we were pretty surprised with this scanner model. It's a pretty big one, and with a diameter that was bigger than our doors. So we couldn't get it through the doors, and that's why we had to move it with a crane through the windows. That was really a big thing, and led to a lot of people, they had to cross this road within the hospital area, and we had a lot of people with their handies and photographs taking this procedure. So loading of scanners varies greatly. Ideally, if you can use the racks, the stainer rack size should meet, of course, the scanner rack size. Continuous loading, mostly only possible with interruption of the scanning process. That leads to a time loss. When we had the GE scanners, that was a real continuous loading, since we had some trays where we put the slides in, and the scanning process was not interrupted, by loading those trays. But with the newer scanners, most of them need to interrupt the scanning process before you can reload or continuous load the scanners. Also, the software is often very, very complex, and routine programs should be one touch and one go. Otherwise, you will have problems with your lab technicians who are not very familiar in, serving all these software features, and that results in probably, delayed scanning systems. And also check what about your mounting medium? Will it stick to the rack, and how long do you need a drying process before you can really submit it to the scanner? So what we learned, that the whole scanning process from loading to reloading varies greatly. So that ranged really from like 2 minutes to up to 10 minutes, which is really, really long. And if you do a whole day's work, then 10 minutes is really much too long. Scanning time for fluorescence is significantly longer. So what we learned is that for a same-day evaluation, or for a same-day sign-out, fluorescence takes a long time, and mostly not, you need an extra scanner for this. Otherwise, if you do bright field and fluorescence for the same day evaluation sign-out, probably it won't work. Check also what about microorganisms like H. pylori or other, like mycobacteria or something that might require Z-stacking, that we might want to check with all your lab stainings and your procedures you have in-house. And very surprisingly, faintly stained tissues like fat is sometimes not completely recognized by some scanners. That was surprising to me, because, when we started with new scanners, that was 2018, that was quite a long while since our scanners on the market. And we saw that like these routine slides over here with fat, which normally doesn't have that much staining because of the diluted fat in there, many of those scanners were not able to probably detect all the tissue, and that was really surprising. And we are going back to the vendors and to the people who developed those scanners and addressed this. And surprisingly to me, that was never a mount. There were scanner contests and whatever, but we never had any report that there's a problem with faintly stained tissues in the recognition in the scanning process. So that is a big deal. And luckily, the vendors took it seriously, and they worked very hard on it, and they have new software released where that problem is really reduced or minimized to a very small amount of dropouts in the recognition of the tissue. However, we still have scanning problems, as you know, like here, the biopsies are over here, and on the cover slip is detected the borders. That means extra scanning time, extra file size. The white balance is not optimal. Then you have this like chessboard phenomenon, or you have this like store effect we call. This is due to a wrong white balance. And over here, you see this artifact causes a focus problem over here in these layers that are scanned, and sometimes really invisible to the human eye. There are little dust particles which are bring the whole scan out of focus. A big thing is the tissue types and the file sizes. These were really paradise times when we had these Omnix GE scanners, which are no longer on the market. You know, the maximum file size was not even a gigabyte as big. And in these times with 3D6 scanners, we're starting with 1 gigabyte. That really affects our whole infrastructure and our storage management. So things you want to do with the scanners. So test the various scanners on site. You will experience how many surprises you will see and how many things you haven't thought of once you have the scanners on site. Test the scanning turnaround time for a certain workflow, like the biopsies, and keep in mind that various stainings come out of the stainers in batches at different time points, not at the same time. So that needs to complete the whole cases. Some stainers might need different scanning profiles, especially if they are not if they are very faint, and difficult cases with special staining features for testing, like what about your microorganisms? Are they really easy to detect with your staining protocols? The same holds true for the fatty tissue I have been talking about. Test also freshly mounted slides. How fast can you put them into the scanner before they really stick to the rack? We have been using cover slips and found that with the cover slips, it didn't work very well. So we moved on to the foil embedding without cover slips. And that really improved our scanning procedure and our turnaround time. And check the lab environment. The scanners are very big. How many scanners do you need? Is there space enough? What about the shock resistance? And check whether or not you have your air contaminated with alcohol or xylene. If so, that might affect your scanner, especially in the sensitive parts like any rubbers or any very significant micro parts of the scanner. That brings us to the bottleneck of the scanner, and I made a calculation for you. So we were calculating based on the numbers we had from the vendors, and the scanning profile we had on site varied from that what we have been calculated before. And these are the numbers we have with the scanning profiles up to date. So we have these two scanners which are capable in scanning 72 slides per hour. We have this scanner which is capable of scanning 45 slides per hour. That brings us to an average of 189 slides per hour. And if we calculate about 1,000 slides a day for the full workflow, that means 6 hours scanning time. Depends on the workflow, whether we want to sign out the same day. That means, okay, we have to start very early. Otherwise, we cannot go fully digital for all pathologists. And that holds true in our lab. So what we can do currently with those scanner equipment, we can go full pathologists can go fully digital, and all others have to go hybrid. Means that they are looking conventionally at the microscope, and after reviewing at the microscope, they bring it down to the lab, and we have overnight scans just to have a fully digital archive for all the conveniences with the digital archive. So how is it organized in our lab right now? This is the sketch of our actual lab. So we have the case collection over here with the routine stainers, and we have the scanners right here, and they need a lot of space. Plus they have an extra PC next to it. So we have it very closely, and we have the immunostators over here, and we have the smaller scanner over here, closely related to the immunoscanners, so we don't lose any time and don't have that much long of a distance to bring them to the scanners. So how can we deliver digital pathology to the pathologists? If you have your equipment set up very well, you cannot start 100% from one day to the other. So what you want to do is bring your staff into that digital workflow. And we designed that kind of biopsy workflow. The reason for that is that we start with the biopsies early in the morning, and these are cut at first time. So lab work starts at 6 o'clock with the tissue embedding, and the first stain slides are ready at 8 o'clock. So the entry of the patient data of a late specimen, all the patient data and all the microscopy and whatever is finished by 8:30, especially for the late arrivals of the previous day. And the cases are assigned to pathologists by 900. So that gives us some time at that point. So when the first slides are ready, we have an hour over that first slides can be scanned already and maybe ready for review at the time they're assigned to the pathologist. So that brings us to the workflow question. I don't know how it works in your lab. I've seen pathology departments who work or who pile up the slides in the lab, and the pathologists just make a visit in the lab and take some cases from the pile and review those cases. So meaning that there is no real digital assignment to the pathologists. That is probably a workflow that will not fit with digital pathology workflow. So you probably need, in order to have your work list done, an assignment. And the question is, how are the cases delivered to the pathologists, and at what time are the slides ready for review that people can start working? So the workstation looks like this, you're familiar with. So minimum requirements, of course, you need an interface to the LIS because you need all the patient data, you need a work list, you need a case overview and slide overview. Of course, we need some information about the grossing notes and the order sheet. Of course, the referring physician, we need to know, because that's maybe important. The previous report, so what was happening with the patient, has any previous biopsies related to this topic, actually. And of course, we just don't want to see it all. We want to make a report. So we need any kind of dictation module or a speech recognition. What I learned, there is no provider out there who integrates it in their digital pathology software. So in this case, you need really to have two windows with two different programs in order to deliver all your diagnosis and finalize your report. And of course, a basic image analysis is optimal. So this is a workflow, how it can look like. These are ready for review. These are awaiting scans. And once you open the case, you have an overview of all the stainings. These are the extra window to make the dictation of your report. And once you have your viewer, of course, you need some navigating window to see where's your biopsies located, and depending on the lab, how many step sections you might want to have on your slide. Are there 3 or 6 or even more, or is it just one? And also you need a control that is an image snapshot of your slide that gives you the information whether everything is scanned, and you can compare it over here that everything is scanned. So most importantly, in the pandemic, we have been able to set up a home office workplace for pathologists. And what really sounds so easy wasn't that easy at all. So finally, we end up in a very, very simple solution that works with a hospital laptop with a VPN connection. Of course, we provide a DP monitor if not this person has such a suitable monitor at home. Along with maybe a trackball or some input device to work smoothly, and a remote connection to the DP workstation we do. In order, we can't have a license of so many licenses because every license costs us a lot of money. So what we can do is via VPN, we can have a remote connection to our workstation, and that works very fine and very, very fast. And also we have the LIS connection via VPN. So we are able to really review all the cases and also have a dictation module to sign out the cases. Also with this one, we can communicate with the laboratory. So order additional stains or order rescans or have some basic communication in terms of, I need an extra step section or please remove bubbles or whatever. So things you want to do, check the software for an easy and self-explaining surface because you want to work on a daily basis and you want to really get all the cases done. Software must be open for the integration of image analysis tool. That's a big fish. It sounds so easy, but what I learned is that the integration of image analysis tools is not standard, and some vendors charge you for that. So meaning if you go to a certain firm and say, hey, I want this tool now, and they said, okay, we can integrate it for you, but you want to pay for that. So check beforehand how much costs will arise and whether or not these costs are really in good shape or not something that the firm uses for advertising their product. A work list, of course, you want to have the folder structure for easy case handling, especially for tumor boards and also for resident teaching. Basic image analysis tools we have been talking about, and of course, export must be possible. That's very important, especially if you consider what we have been hearing about the image analysis tools or the artificial intelligence tools. So that brings us to the perspective of the AI tools. As we heard, that can support the pathologists in diagnostic steps, detection of specific alterations, classifying and quantifying parameters, and identify prognostic features. And as we know, you probably, only for those who are not very much familiar with this, the deep learning works mostly with the convolutional neural networks. That means the image is divided into patches and into convolutional layers that are locally transformed into images. These are connected by neurons, and these neurons are connected again. That produces a new image on our monitor. So examples you're probably familiar with here with prostate. So with this image, and after validation of your stainings and your files, you can have the support by the cancer heat map, but also with the Gleason heat map that indicates you what kind of pattern is prevailing or predominating. So how can we use it? So currently we are trying to get comfortable with all this. So that means we have two phases, and with this workflow we're working in the first phase with the second read. That means after scanning, pathologist is still reviewing, and also the software is reviewing the slides. And then there's a feedback whether or not the review is complete, and the final diagnosis can be made or something may be overlooked. But this will be followed by a second phase where we have the first read. So after the scanning, the software reads my slides, and then it comes back to the pathologist and it says, oh, look over here, this might be cancer in this way. And then we can set up a final diagnosis. So having said this, that sounds so easy, but also this one needs a really careful setup because again, you need to guarantee that all data are matched really with the slides and from the patient. So in the second read workflow, so the slides are delivered to the pathologist, and the pathologist makes his diagnosis, and this one is fed back to this engine. This runs in the background after the AI analysis, and this is also compared with the diagnosis from the pathologist and gives you an alert or not, and the pathologist can review and give up a final diagnosis. Well, this is followed by the first read. Once we get comfortable with this one, that means everything goes into the AI analysis tools and the classification engine. And after everything has been going through the quality check and the various algorithms, this goes to the case reviews for the pathologist, and the pathologist finally signs it out and sets the diagnosis. So again, have in mind, I also thought that would be an easy thing to set up. Currently, it's not. So what you need is really have a close interaction with the scanners, with the scanning profiles, with the resolution, with the file export and the formats, and with the AI tools that have certain requirements for all this. And the problem can be that the scanner profiles you have in your lab does not match the requirements of your AI's algorithms and software. So that might need some adaptation, which again has some influence on your workflow that might prolong your scanning profiles and then prolong your whole workflow. So as you see, and we heard earlier today and maybe later today, the perspective is very good. With the Gleason score, things can be seen by the pathologist in the machine. And the future is hopefully that the machine sees something that the pathologist does not see. So based on an H&E and the algorithms, we are, when this model, the AI tools are able to predict a prognosis just based on the AI tools. And that's very important. And I think that will be the future, and I hope this will bring us into the brightest future. So having that said, I hope I could give you a little overview on what the way into digital pathology can mean. And there's really a lot to discover, but also a lot of work to do. And I'm happy to take any questions. Thank you very much.
Yes, thank you very much, Rainer, for this very, very nice overview and illustrating of how we or what we actually have to take into account and keep in the mind when going digital, and telling about your experiences. We have quite a lot of questions already received in the chat. I think we might not be able to answer all of them, but let's start maybe with a few, because I think that there are quite some questions that of course arise when we see what you have just presented. For example, maybe starting with that one, when we are thinking about going digital, what do you think? Where's the major challenges, the most serious challenges in going digital with regard to the workflow? You showed a lot of details, but what did surprise you the most? And you already gave the idea that it might be good to start with a single organ or with a single domain. But what were actually the most challenges? To convince people to establish the infrastructure, to build up new SOPs? So can you share some light on that?
That's a good question, and thank you for that. When starting, the biggest challenge is to get everything on a table. That means the LIS provider, the DG provider, and your hospital IT. And this is not very easy to get them all together, because they need to work together very smoothly in order to get all the data managed and everything so that you have a very good convincing workflow for the pathologists who are not familiar with digital pathology, because you need to convince those guys. And coming to that question, so have them involved early and see how it runs, and then according to your workflow already set up. I gave that example with the biopsy workflow. Make a realistic workflow that can work and gives also some advantages for the lab. So if the lab needs to assign all the slides anymore, then they don't need to sort out the slides anymore. That gives them extra time. And also for the pathologists, as soon as the cases are assigned, they can start right away in really diagnosing. They don't need to run into the lab and see whether the case is present or not. So this is the advice I can give you. So from this part. So first of all, but really have all your IT people together. Otherwise, it's really a mess.
Mm-hmm. How do you deal with rescans that are required due to quality reasons? So when and how do you detect that this is required to do a rescan, and how do you actually carry this out then?
Yeah, a big topic, extremely big topic that needs to resolve all the problems you might have in your lab in doing the sections. So all the technicians must be really advised how to do the sections. And secondly, the scanner profile must be set appropriately. So I could have talked for hours about this. And also what we found out, the glass of the slides is important. We had the glass slides of various vendors, and with a naked eye you can see a difference. But the scanners saw that at some vendors they had something in the glass which really made trouble, and we ran into a lot of problems, and we switched the vendor with a different quality of glass. Then we didn't have those problems anymore. So that's quite of a process that took us about half a year. So currently we have rescanning rates between 1% and 3%, and that is probably the maximum you might want to have.
And when do you detect this? So does the pathologist finally, when they do the diagnosis, see, okay, that's insufficient, and then it goes back to the lab and
Yeah.
rescan? Yeah.
So what we don't do, we don't want to lose the time that the technicians win in not sorting into the slides anymore, sitting in front of a monitor and checking every slide. That's really boring. So you can't really convince anybody to do that.
Yeah.
So, yeah. So what we do is we set up the program properly, and the quality control is up to the pathologists. Sometimes it happens that not everything in the scan is really in focus, but that might also be in areas that are really not diagnostic. So you don't need a rescan for that.
Yeah. Two last questions. First, how do you handle backups? So how long do you store the scanned data? Forever or just for a few months? Or how do you handle this? And what's the resolution actually you're scanning? All the same, 20x, 40x?
Now we're scanning it with a 20x objective. So that results in a 40x end magnification. We are currently storing everything. We don't want to dump it because we have seen, excuse me, we have seen the biggest advantage is really to have that archive. I've been working quite a lot more because I don't need to run to the archive anymore. I can really review slides within 2 mouse clicks. And sometimes I get a call from a clinician and he asks, so how has it been looking like 2 years ago? And I can answer, or he says, like 2 weeks ago, you have been diagnosing something like this. What about the other one parameter? I can hold it up on the screen and see, okay, it's like this and this. And that's really amazing. So currently we have the strategy not to dump those, but I know that it is a problem with the storage, but we have the strategy now for 5 years in mind, that we think within 5 years, the developments are like this, that it becomes cheaper and easier.
And the last question, you showed us that, especially in the pandemics, working from home office, that you worked using RDPs or remote desktop connections. And what I find quite fascinating is that actually the speed in an RDP connection is kind of not as the same as when you sit in front of the PC and have the monitor directly connected. So and for a long time, this was always the discussion that the viewers are too slow, that the slide reading is too slow in virtual microscopy, and it's not the same like in the digital in the light microscope. So, but now you illustrate that you could even use that via a remote connection. So doesn't this speed not count anymore? So does the view changed, or how do you cope with that issue actually?
Excellent question. It has something to do with your internet connection at home. So luckily in Switzerland, we have a very good coverage. So if you have a bad internet connection at home, it's not really fun. It's not really fun. Yeah.
Good. We have plenty of more questions, but we really have to move on with the session. Again, thank you very much for your great talk and for answering these questions. If you have some time, please take the time to also address some of the questions in the chat directly. And we would move on now to our